Hello, this is Mrs. Thompson, your instructor returning, and we are continuing with examples of computing angular and linear velocity. First, computing angular velocity. Example, the propeller of a small airplane is rotating 1600 revs per minute. Find the angular velocity of the propeller in radians per minute. Well, our formula for angular velocity is the central angle divided by the time. The time can be a little tricky to find, but if we pay close attention, it's the problem state 1600 revs or revolutions per minute. So this means 1600 revolutions for every minute, meaning the amount of time is 1 minute. Therefore, we plug in for our time 1 minute. Our angle theta, we see that this time we're really not given an angle measurement such as so many degrees in the problem. However, we know that this propeller on this airplane is rotating in a complete circle. Because of that knowledge, we know that our angle is 360 degrees, a complete circle. It needs to be in radian, and of course we know that 360 degrees in radian is 2 pi. So when our propeller spins once, one complete circle, the angle measurement is 2 pi. However, we know that our propeller is not spinning once, it's spinning 1,600 times. So our angle is 2 pi times 1,600, which is 3,200 pi for our angle. Plugging that into our formula, of course, we find that our angle measurement is 3,200 pi. There's no need to write an understood denominator of 1, so our denominator is just our unit, minutes. Of course, our angle measurement contains pi, which means it is in radian. So we have met the requirement of our directions that we have the angular velocity and we have it in radians per minute. To continue with examples, you need to know the relationship between linear velocity and angular velocity. If the angular velocity, omega, or if omega is the angular velocity of an object moving along a circular path of radius r, then the linear velocity v is given by v equals r times omega. So in short, you must remember at this point, you have two formulas for calculating linear velocity. The one that was previously shared with you, linear velocity equals the arc length divided by t, and now linear velocity equals the radius times the angular velocity. So when performing calculations, if you do not have enough information to use one formula for finding the linear velocity, please remember that you have another one. Also, this second formula that we have right here is a much quicker method for finding or calculating the linear velocity if you already know the angular velocity. Let's move on to an example. Calculating linear velocity. Given in a previous example, the propeller of a small airplane is rotating 1600 revs per minute. Find the angular velocity of the propeller in radian per minute. We just worked this example out. It was our previous example. Suppose the propeller blade is 2 and 2,500 meters in diameter. Our new problem is find the linear velocity in meters per minute for a point located on the top of the propeller. Well, we have already calculated our last problem. We calculated the angular velocity for this propeller. We found that answer to be 3,200 pi rads per minute. We can plug that answer right in for the angular velocity. To get the linear velocity, we only need to multiply that by the radius. Of course, the radius is half the diameter, so the radius of 1 and 125 thousandths was found by taking the diameter of 2 and 25 hundredths and dividing it by 2. Multiplying straight across, we get an answer for linear velocity of this propeller as 3,600 pi meters per minute. Meters because the blade was measured in meters. This is the exact answer. An approximate answer, plug it in 3.14 for pi, multiplying it by 3,600 is 11,309 and 73 hundredths meters per minute. Concluding this video with an example of computing linear velocity, this time when the angular velocity is not known. So you have an example using both formulas. Example, a Ferris wheel is approximately 60 feet in diameter and rotates 1 rev per minute. Find the linear velocity in miles per hour of this Ferris wheel at the outer edge. Of course, the outer edge is where the individuals riding the Ferris wheel would be sitting. Well, we're asked to find linear velocity. That formula is S, the arc length over the time. Once again, we are told that something rotates. This time it is a Ferris wheel, but it rotates 1 rev per minute. Per minute, again, meaning our time. What we plug in for T is 1 minute. So that can be substituted in, plugged in. Now we just need to take care of plugging in for our numerator, which requires S, the arc length. Well, going back and finding it, calculating the arc length, we know this Ferris wheel is going around in a circle, which means 2 pi would be the angle in radian. This time 2 pi, unlike the airplane propeller problem, will not be multiplied by anything or anything other than 1. The amount will remain 2 pi because this Ferris wheel is only making 1 rev per minute, not more than 1 rev. So our radius, half of the diameter, which would be 30 feet, times our angle 2 pi, gives us an arc length of 60 pi feet. Going ahead and plug it in, 60 pi feet for the arc length. We have our velocity at this point, our linear velocity. However, the problem is not complete because the answer is required to be in very typical units in miles per hour. Right now, we're in feet per minute, which means our distance, our feet, they must be converted to miles. When converted, we multiply by a unit fraction with the fact this time 1 mile is equivalent to 5,280 feet. Whatever unit you're going away from that unit needs to cross cancel out. So the 5,280 must go in the denominator so that the feet will cross cancel out, leaving us with the only unit of length being miles. Likewise, our time is in minutes, but we need to get it to hours. That fact, of course, for conversion, is that 1 hour is equivalent to 60 minutes. We need the minutes to cross cancel out. For this problem, that will require minutes in the numerator, 1 hour in the denominator. The only units we're left with now are miles. After the cross canceling are miles an hour. So we are done. We have our miles, we have our hours. Fraction bar in between is read as the word per. Once we multiply straight across, 60 times 60, denominator, 5,280, and then divide to get an approximate answer of a speed of 6,800 miles per hour. So this Ferris wheel is traveling a little bit faster than a half a mile per hour, so not too fast. One that's probably for overlooking the area and enjoying the view.